guys, chapter 4, lesson 4, adding and subtracting unlike fractions. So what do you think what I mean by unlike? What do I mean by unlike this time, Jasmine? Yeah, say we're going to have different denominators. So we're going to have to work on changing them. We kind of talked about this a little bit, gosh, a few days ago. Another thing that's going to get thrown in is you're going to have negatives and positives again. But other than that, I don't even think they're mixed numbers this time. So I think it's just simple stuff, kind of like we did yesterday, all right? Except for they're going to have different denominators. Now, how would I add and subtract different fractions with unlike denominators? What am I going to have to do, Kaylee? Yeah, I have to find a way so the denominator can be the same. And if I change the bottom, do I have to change the numerator then? Yeah, I have to change the numerator, so don't forget that. Nice job. All right, so we kind of talked about this a little bit yesterday. Now let's just talk through it instead of writing it down. What would I do here? Somebody tell me what I'm going to do to add this. Henry. Yep, I'm going to have 8/9, right? Reducible? No, 8/9 isn't reducible. What about this guy right here? It's kind of like the one we just did a little bit with the negatives. What am I going to do here? Somebody other than Henry. Jasmine. Okay, so I'm going to have 8/6. Then what am I going to have to do? Mixed number and then eventually reduce. So, good. You guys are on the same page there with me. Okay, what are unlike denominators? We talked about this already with my bell ringer. They don't have the same bottom number. And what are some strategies to make like denominators? Kaylee said find a number you can multiply them both to make them the same. Okay, what's another strategy? Do you got another one? Yeah, find out what number they have the same. Yeah, definitely, Zane. Yeah, if you don't if you're not sure, and you're like, oh my gosh, I don't know, just multiply the two bottom numbers. If you multiply the two bottom numbers, that's going to give you a number they both go into. I cannot take you seriously with those classes. I love it. That's so great. All right, so add and subtract fractions with like denominators. We have to make them common. So let's look at these two right here. What's something that's common with them? Yeah. Yeah, definitely. 15. 15 here, 15 there. I like to rewrite the problems. If I were you, please rewrite the problems for yourself. Okay, so how do I find this top number here? What am I going to do to find these top numbers? Cadence. Yeah, so this is going to be 9. Oops. And this is going to be, and that's going to be 5. Now, can I subtract? Yes, I can subtract. I get 4. 15. It's reducible? No, not so much. What about this one right here? What number can I use for the denominator here? Jacob. Yep, I'm going to keep 22. So do I don't have to do anything to this one? No, just this one. 22. What times 2 gave me 22? 11. So what am I going to do with this one? Multiply by 11. Oop, 22. And you get 18 over 22. Reducible? By what? 2? 9/11ths? Should be my answer. Not so hard, right? You guys have done this before, probably. So you've been blue in the face, I feel like. So, anybody still want this to take an example? We'll do a few more examples, so. Why don't you do these two by yourself? Why don't you do these two by yourself? And then we're going to start talking about throwing some negatives in there. give you a few more seconds to finish up. Somebody talk to me. What'd you do for the first one? Kaylee, what'd you do? Okay, so you changed that to 2/16, so 9. What'd you get for an answer? Can you reduce it? Nah, not reducible. Nice job. Somebody talk to me about this one. Ryan, what'd you do for this one? Okay. Okay, so you took it and you used 40 as a denominator. I see. Okay, so then this one you have 40 plus 12, or I mean 12 over 40. Okay, and then you probably got 22 over 40, and then I'm assuming you reduced to 11/20ths. Can I use a different denominator up here than 40? What could have I used, Cadence? Yeah, I could use 20. But did it matter? Are you going to reduce to the same thing anyway? Yeah, it really doesn't matter. So as long as you find something that works for you, and then you can get it reduced, that is just fine. All right, so now we're going to throw in those negatives. All right. First thing you're going to do, change the denominators. Change everything to make them similar, and then worry about your negative sign. Okay? So I'm going to use 6. So this is going to be 6 minus 6. 3 times 2, so 2, so it looks like this. Okay, so that's my new problem. Rewrite the problem. And the first thing you need to do is change those denominators. Now what am I going to do? Henry. Yeah, how did you know I had to do that? And there's a, negative. So I'm going to keep this, and then what am I going to do? Change this, and then change this. So then I get 6, and then I have -4 plus -3, -7. Don't forget your signs. And then change to a mixed number. Okay. What's another way I can change to a mixed number? If I can't do that in my head, what's another way I can do it? Kaylee. Yep, I'm just going to divide. Just going to divide. Why don't you try this next one in your notes? You try this next one. All right, Zane, what to do? Okay. So times 5, so that would be 5, times 2, so this would be 4, and it looks like this. Then what'd you do? Somebody else tell me what'd you do next. Jacob? So you kept this, and then did you change this? And then you change this? So your answer should have been what? 9/10. 9/10. Nice job. I've noticed in a lot of people's homework, not in this class exactly, it might have been a little bit in the other class, I noticed how even if they have a plus sign here, let's say they said 1/2 plus -2/5, they try to do keep, change. When's the only time you ever need to do that, Connor? Subtracting, because we want to change that to an addition problem. That's our goal, is to change to the addition problem. So if you change an addition problem to a subtraction problem, is that totally defeating the purpose of what we're trying to do? Yeah, so you want to do that only in subtraction. All right, I'm going to give you another one. Are you ready? Okay, let's do 3/4 plus negative half. You solve that one. You gotta keep change on this one? No, not at all. Not at all. So far, so good?